Okay, so in this video, we're going to be talking about on the circle intersections. And on the circle intersection takes place if a secant and a tangent intersect at the point of tangency. And then the measure of each angle formed is going to be equal to half the measure of its intercepted arc. So as we're going to see, this is going to be very similar to inscribed angles, which we discussed earlier. So we have angles 1 and angles 2 here. The measurement of angle 1 is going to be equal to 1/2 the arc it intercepts. The arc it intercepts is arc AB, so the measurement of arc AB. Again, that looks just like how inscribed angles worked. And so also with angle number 2, the measurement of angle 2 is going to be equal to 1/2 the measurement of arc ACB. Now we're going to go ahead and apply this in some examples below. So if we look down here, it wants us to find all arcs and angles. We are given arc AB, and we're going to go ahead and find our first angle here, BAE. And like we said earlier, so the measurement of angle BAE is going to be equal to 1/2 the measurement of arc AB. So 160. 160 divided by 2 is going to be equal to 80 degrees. So we know this right here is going to be an 80-degree angle. And then using what we know about properties of lines and angles, angles BAE and BAD are on the same line, so they'll form supplementary angles. So angle BAD is going to be equal to 100 degrees, and that is because 180 minus 80 will give us 100. And then we can go ahead and apply either a circle being 360 degrees or our on the circle intersections rule. Let's do that for the sake of new learning. We know our angle is 100 degrees is going to be equal to 1/2 of arc BCA, or we can just say the measurement of arc BCA. So if I just multiply it by 2, 200 degrees is going to be arc BCA. So 200 degrees. Great. So again, we got all of that just from one angle that we were given, that being arc AB, or one arc, that we were given. And so let's go ahead one more time and apply this to more of an algebraic example. So in this question here, it wants us to determine the measurement of arc ACB. And that's going to be this arc over here. First, what we're going to want to do is figure out what each of our angles are. And we can do that through solving for x. Now again, like we saw in our previous example, both these angles added together should be equal to 180 degrees because they're supplementary angles. So we'll start by setting 2x minus 4 plus 4x plus 16 equal to 180 degrees. So when I combine my like terms, I will have 6x plus 12 equals 180. I'm going to subtract 12 from both sides. So 6x will be equal to 168. And I divide both sides by 6. I will get x is equal to 28. Now, if I'm looking for arc ACB, I would probably want to find angle BAD first, because that's going to be equal to 1/2 of that arc measure. So I'm going to go ahead and plug in my 28 in for my x here. So I'll have 4 times 28 plus 16. 4 times 28 is 112 plus 16. That will give me 128 degrees. So this angle here is going to be 128 degrees. And again, we know that 128 degrees is going to be equal to 1/2 the measurement of the arc ACB. So if I just multiply that by 2, I will know that the measurement of arc ACB is going to be equal to 256 degrees. And so that would be my final answer.